Introduction. When an object changes its position with time, it is said to be in motion. Cars, buses, trains, aeroplanes, etc. are the objects that first come to our mind when we talk about motion. However, yet another object has motion. Try to recall a big grandfather clock. Do you remember seeing at the bottom of the clock a long stick with a ball attached? That is a pendulum. It moves back and forth in harmony with the tick-tocks of the second hand. In this lesson, we discuss the simple pendulum, or simply the pendulum. Objectives. At the end of this lesson, you'll be able to describe a simple pendulum, define oscillatory motion and time period of a simple pendulum, differentiate between uniform and non-uniform motion, plot distance time graph. Have you ever observed a wall clock? A simple wall clock or a wristwatch has a circular dial with 3 needles. The circular dial is divided into 12 equal parts, with each division representing 5 minutes. Observe the dial more closely and you will find that it has 60 smaller divisions in it. A single small division represents 1 minute. The longest needle, which moves the fastest, is known as the second hand. It completes 1 revolution in 1 minute. The smallest needle, which is also the slowest, is called the hour hand. It completes 1 revolution in 12 hours. The needle smaller than the second hand and longer than the hour hand is the minute hand. It moves slower than the second hand but faster than the hour hand. It completes 1 revolution in 1 hour. A simple pendulum consists of a small metallic ball suspended by a thread. The metallic ball is called the bob of the pendulum. The thread by which a bob is suspended is loose at the lower end and is fastened at the top to a stand. When the pendulum is not moving, it is said to be at rest. This position of rest is also known as the mean position or the equilibrium position of the pendulum. Students, let's quickly check what you have learned. Select the correct option and drag it into respective box. Suppose the bob of a simple pendulum is in equilibrium. If we now take it to one side, left or right, and release it, it begins to move to and fro. This to and fro motion of a simple pendulum is called the oscillatory motion. 1 full to and fro motion of the pendulum is called an oscillation. The pendulum completes 1 oscillation when its bob, starting from its equilibrium position O, moves to one extreme position A, from there to the other extreme position B, and then back to O. Alternatively, an oscillation can also be measured as the movement of the bob of a pendulum from one extreme position A to the other extreme position B and back to A. The time taken by the pendulum to complete 1 oscillation is called its time period. You can compute it with the help of this simple exercise. Take a simple pendulum. Let it come to rest. Identify the equilibrium position O on the ground below. Now take the bob to one extreme position A and identify it on the ground below. Start a stopwatch and release the bob at the same time. When the bob comes back to the extreme position A, note the time on the stopwatch. Repeat the activity. This time, start from the equilibrium position O. Note the time taken by the pendulum to complete the 1 complete oscillation from O to A to B, B to O. The time so recorded is the time period of simple pendulum. Motion can be classified as uniform or non-uniform depending on the speed of an object. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. A bus, for example, moves at varying speeds over varying stretches on its long route. Hence, its motion is non-uniform. If an object moves along a straight line at a constant speed, then it is said to be in uniform motion. A car, for example, may maintain the same speed when it covers a short distance. Motion of objects can be presented in pictorial form with the help of distance-time graph. For this purpose, first draw a horizontal line to represent the x-axis and a vertical line to represent the y-axis and mark them as OX and OY. Measure time along the x-axis and distance along the y-axis. Mark values for the time and the distance on the respective axes. Now plot the points on the graph paper, each pointer presenting a specific combination of distance and time values. Join all the points on the graph to get a linear distance-time graph which shows that the vehicle is moving at a constant speed. From this graph, we can calculate the distance covered by vehicle at a particular moment. We can calculate the time at a particular distance from the starting point. In the same way, we can calculate speed also. Fill in the blanks with the correct answers. Summary. Let us summarize what we have learned. To and fro motion of simple pendulum is called oscillatory motion. Time taken by simple pendulum to complete one oscillation is called time period of simple pendulum. If an object moves along a straight line at a constant speed, its motion is said to be uniform. If an object moves along a straight line at a speed that keeps changing, its motion is said to be non-uniform. Motion of objects can be presented in pictorial form by their distance-time graph. The distance